All right, guys, let's get started. Might as well. So I'm going to be talking about episodes 11 and 12 of Star Trek Discovery, and we're going to be talking about the science, the astronomy science in these episodes. Now, remember, I am not a biologist. Not a biologist. There are lots of things in these episodes that a biologist could talk about, such as Klingon human memory brain implant thingies. I am not touching that with a 10-foot pole. So you are here to hear about mirror universes, multiple universes. We're also going to be talking about just some of the fun things like how transporters work. If you were to transport someone into space, what that would do to them. And then some of the quantum signatures of this mirror universe that have been discussed a few times. And one awesome thing that they managed to get super right at the beginning of episode 12, the most recent one. I don't know if they intentionally did it, but I did the math and it worked out perfectly. So that was pretty exciting. So let's just jump right in. Why not? As always, feel free to ask questions. We can derail the conversation as much as we want. I usually try to stick to between half an hour to 45 minutes, just so we, don't go too off the rails. And then I'm going to start doing a little bit more of these, just as fun classroom type discussions where you guys can just ask whatever you want about space, because why not? Space is awesome. All right, so let's just kick it right off. So they're in the mirror universe. This is bad. This is not good. As they're going through, and again, this is beginning of episode 11, they kind of are starting to figure things out, figure out what's going on. And one of the things that they mentioned at the very beginning of this episode is that they're having power issues, like these big electrical fluctuations. And this sort of disappears. Yeah, they kind of fix it, as it were. But the first thing that jumped to mind for me is, remember, they said that there's like a different quantum signature for this universe that they're in. So that would make sense if there's a different quantum signature, if the power fluctuations were a little bit different. And remember, I said something like this before where they were trying to do they were scanning one of the data packs that they had found with their own ship's technology, and they were able to interface with it okay. So it's a bit tricky to know how much these power issues are coming from the fact that they're in a different quantum universe, because if they're in a different quantum universe, one of the physics theories is that that impact comes when you actually have different quantum fluctuations. So your fundamental particles are going to be slightly different than they are here. And so the speed of light, for example, may be slightly different in a different quantum multiverse compared to ours, but then everything's relative. So if you're from that other universe, you don't notice it because everything is the way it is. But traveling between the two doesn't work so well. For example, power going down. So we'll kind of go with that. I don't remember if they discussed or went into any more detail than that one. Again, it was a couple weeks ago that I watched this. But having power issues, things aren't going great in this new multiverse, and they're talking about Forrest, and Stamets is sick and not doing so great. So then they go to the ISS Shenzhou, where Burnham is the captain. And they transport people who have broken the law or angered the captain into space to die. Morbid. Okay, but my question from that was, first of all, how do transporters work, and can you kill a body by doing that? And what happens if you transport a body into space? Can you? Should you? And what actually happens? So the physics of transporters, I know I've talked about a little bit before, but it's kind of fun. It's kind of cool. And science. Technobabble in Star Trek has come up with ways to explain transporter technology. Basically, what happens is Star Trek canon is divided on this. There is no one of these two ways. There are episodes supporting one side, episodes supporting another. I know we've talked about this before, but for those of you who may not have been on those discussions, those deep discussions, heavy discussions, basically it's either, okay, it breaks your body down to its tiniest particles and moves them, actually takes those particles, transports them, and then rebuilds those original particles, or it maps out all of your particles, kills you, and then rebuilds you on the other side. And like I said, in the Star Trek realm, there are episodes that cover both of those scenarios. So the way they kind of show it here lends itself to the break it all down, move the particles, and then rebuild you, because they don't need a transporter pad to end up there, and they're just being rebuilt. So not great. But one of the biggest issues in actual physics that we have with transporter technology is the Heisenberg principle in quantum physics. And this basically comes down to the fact that you can never know precisely where a particle is. Like when you break it down, you can't say it is here. Now, that seems a little bit ridiculous because we can go, oh no, it's there. But the more exact you get to it, actually, the Heisenberg principle means you don't know how fast it's moving. So you start to lose information. And I'm talking down to can't actually visualize it. You need special equipment. You're going down to fundamental tiny particles. And that's really hard to do. So the more you get precisely where a particle is, the less you know about its speed. I can't help myself. There's a dorky physics joke about this, that a cop pulls over Heisenberg and says, "Sir, do you know how fast you were going?" And he says, "No, but I know exactly where I am." Because you know one or the other, but you can never know both. And if you want transporter technology, that's a problem. But thankfully, Star Trek Technobabble solved this a long time ago, because the Heisenberg principle was the main thing that makes transporters hard. From a fundamental physics doesn't allow this perspective. And so they have Heisenberg compensators. O'Brien is frequently seen to be repairing Heisenberg compensators. So well done. But the question is, we're talking about the vacuum of space, zero gravity. If you could move all these fundamental particles, and you happen to know exactly where they are thanks to your Heisenberg compensator, how would you actually rebuild those in space? And is that a good thing? And can you actually rebuild it? And then, you basically die instantly, because all of your little particles are being rebuilt in a vacuum. So it's not even like the outside, then the inside is getting exposed to the vacuum. It all gets exposed to space at once. So not ideal, but kind of a cool visual. And it just made me think about the transporter technology and how that actually works, and some of the difficulties with it, and if we're actually doing it in space, what impact that has. Because I was also thinking, well, maybe if you don't have gravity, that they're not able to reassemble in the right way. But I think they probably could, as long as they knew exactly where it was. But you wouldn't even know you're in space, because all of you would just dehydrate instantly and freeze instantly while you were being reassembled. So fun, morbid, death by space. All right. So going on from that, there's a moment here. First of all, as original Trekkie fan, I love that they're going back to the just discs, the cards that are just plastic as their data discs, as we've seen in the original series. And they actually do some, you zoom in and you can kind of see some more detail on these discs, which is pretty sweet. But yeah, essentially what happens here is that Burnham talks to Saru, and through their sort of hologram AR type communication, which is pretty cool. We've talked about that before, that we basically have that technology. We just need to wear something in order for that to happen. Here they automatically have it. But she says that she has this classified data, but it's too big to be able to transmit. So they're going to need to find another way to get it to them. And what crossed my mind is well, you can't transmit just these bytes of, data that you have. But you can somehow do a full hologram discussion that's data. Like that's streaming a signal, and I assume quite a big data signal, because that's kind of problems that we have trying to be able to do that sort of stuff. So basically what it comes down to is that's a heck of a lot of data that she's got on that little stick that she's not able to use from that. So then they go to try to have this like quorum with the rebellion, and end up on an awesome looking Vista. Now I think this might have been filmed, I didn't look this up, but it looks like the sort of cratered lake in Idaho, I want to say. But pretty cool vista, mostly volcanic type rock. But this is a fun thing that astronomers do. Maybe it's just fun to us. But you're here watching an astronomer talk about sci-fi, so this is what we're going to do. When you go to other planets or vistas or anything like that, you try to think about how they could exist as exoplanets. And like I said, this place reminds me of this Craters of the Moon, that's what it's called, in Idaho. Now it's called that because it resembles the moon. And but this looks like a ton of igneous type rock. There is no plant life to be seen. And that's about it. But they don't seem to, I mean, obviously the gravity's fine and the air is fine because science fiction. If it wasn't, that like makes the budget a lot harder. So they're on this Vista, on this planet, and again, no planet, like this is an exoplanet that is likely to exist. By exoplanet, I mean a planet that is orbiting another star that's not our sun. So outside our own solar system. Now it can resemble our moon. Our moon is called such just because it's actually going around the Earth and it's a moon. But if it was just going around the sun by itself, then it would be not that. So anyway, all right, now we are going to talk about these blaster guns that they have, because as they're sitting there, they're trying to sort of see what's off in the distance and try to see the, try to locate their contacts. And the problem with that, it's not a problem. They just have like these weird blaster rifles, and what's going on with that is he fires it, and it causes it to explode. And I don't know if they're firing like grenades or if they're firing, or if, this is what I was thinking, is that they have these big plasma like explosions that are happening, and they basically interact with this sort of igneous rock to cause a big chemical explosion. And I'm thinking of like the Gorn episode from the original series where they're able to do that. So it's getting in the weeds there. There's no evidence one way or the other, but this is, you know, for kind of people who like cool sci-fi weapons. These are cool sci-fi weapons. Caused big fiery explosions. Awesome. And made cool noise and fired big green plasma type things from them. So that's fun. All right. And then carrying on from here. So yeah, the reason I paired up these episodes is because I did episode 11 and 12. Because episode 11, bless, good episode, lots of fun content for the viewers of the show, but not a ton of astronomy in it. And yes, people were asking me about mapping Klingon into human into Klingon, and that's hard and complicated. So not a biologist, that's squishy, weird stuff. So the last thing from this episode that I wanted to talk about was the fact that they beamed Tyler into space to kill him. Remember, Burnham said, "I want it to be me." And she goes in and she transports him, and immediately he gets transported onto Discovery and is apparently fine. Now, remember from the beginning of this, when I was talking about what happens when you get transported into space, you don't survive from point zero. You're never going to exist. Yeah. Not ideal. Not easy. For somehow, he was able to just defrost immediately and be fine. Again, just trying to reconcile how transporter technology actually works is not with transporting into space and then transporting again onto a ship, because death and pain happens instantly. Still haven't figured this out. We will do our best. We will continue to sleep on this and see if anything comes from it. But remember, now I told you that she couldn't beam the data, all the classified data that she had, because it was too big. And so, sneaky, she put the disc on him, onto Tyler, and he was fine. So, question from Neostar: could it be because he was originally Klingon? I know not a real thing, but maybe that's the out. But he's biologically mostly human, disguised. I know they had signatures of Klingon, the brain waves. But again, human or Klingon, when they're being transported, it's breaking down all of their particles, then moving them into space, the way it's done in this episode, and rebuilding them. And so if they're rebuilding all the fundamental particles, then those are all exposed to space from point zero. So I'm not sure. But I like the way you're thinking. Maybe we'll go with the Klingon route. I like it. Again, going to continue to think about it, see if there's anything else that comes from this. Because we got to come up with it somehow. He was able to survive and be beamed back onto board. One thing I was maybe wondering is if it was just like, I don't know. What if we thought about it the other way? What if Arcantrix, what if all the particles were reassembled instantaneously? That would help as well. Yeah, if they were just like, oh, and you're together, then you would be fine. And that might work with the other explanation for transporters that also works in Star Trek, because we have episodes that go both ways. So instead of moving your particles and reassembling you, it maps where all of your particles are and then rebuilds you. But instead of rebuilding you, it goes boom. And then you could survive this. You'd be frosty for a lot longer than he is. But otherwise, I think you can get away with it. So maybe we'll give him a pass on this one. If it's just that instead of rebuilding you, it's just you're there. I mean, if we have Heisenberg compensators to allow for knowing exactly where the particles are, then maybe we can get away with that. So we'll let that go. All right. So that's the end of episode 11. And I just put this on there because it was an awesome ending. Maybe it's a philosophical difference in dying and not. Philosophy in Star Trek is not my field. But correct. I mean, again, I guess you could go into that even more than just dying in space with transporter technology. Is that like how dead is Tyler with Voq inside him? You know, so yeah, the philosophy of Star Trek is a whole other thing that we could do. All right, so on to episode 12. All right, this is it. This was awesome. This worked out so well. I couldn't even believe it when I did the math. So every time they throw out numbers in Star Trek, I'm like, ooh, can I calculate anything from this? And they said, okay, the Karen, the ship that they're going to, this is when Burnham and Lorca are in the shuttle. The Karen is 27 million kilometers away. They say that. They say coordinates are classified, but it's 27 million kilometers. And then she sets it on autopilot, and then she gets and talks to him, and you see the ship kind of go into warp, and then a little time later, it gets there. Now I was like, all right, let's calculate what factor warp this would be. Because they're traveling 27 million kilometers in a not significant period of time. So so there must be a warp something. And the visual says, well, let's warp something. So I was like, well, how many times the speed of light is it going? And basically what I got down to is if you're going exactly the speed of light, it would take you 90 seconds to get 27 million kilometers. So you're going the speed of light, and it takes you 90 seconds to go 27 million kilometers. And I don't know if they did this on purpose or not, but the second the ship goes to warp to the second that it comes out of warp is 90 seconds. So they are going the speed of light, exactly the speed of light, 1, V equals C, which was awesome. And I was like, well, maybe it's about a minute and a half. I'll go back and I'll time it. And literally from warp to out of warp, it's 90 seconds. So well done. We'll call that warp 1, that all they're doing is compensating for their mass in the space-time thing, and they're able to coast along the surface of space-time at the speed of light. Big thumbs up. That was the most exciting science thing that they did. It actually worked exactly. Moments like that are beautiful. It's just a beautiful moment. So it's not significant other than we're going to call whatever warp 1 they were at, whatever warp they're at. They weren't necessarily building a warp bubble around themselves. All they had to do was compensate for the mass of the shuttle to bend up space-time so space-time was flat, and then just coast as if they were, because they were going at the speed of light. So I loved it. That was just beautiful. I'll stop. Okay, obviously I have to talk about this. I'm going to talk about it later, near the end, a few minutes. But basically, this is the Karen, the ISS Karen, or Sharon, the Greek word, Pluto's companion, another dwarf planet in our solar system, and Charon. Okay, I'm done. You know what I'm talking about. They showed this shot. And I went, oh, that's an interesting shot. That looks like a star. But this is a starship, and that is way too small for a star. Now, it could be a neutron star. Neutron stars tend to be they can be about 10 kilometers, 20 kilometers, about the size of cities. And this seems like a pretty honking big palace starship that you could argue that maybe it's a neutron star. We have no information on how it's powering the ship. It looks like that's what it's doing, is that it's somehow in the core of this ship. But beyond that, we don't have a ton of information. So I'm going to come back to that. But if you watch this episode, you've definitely seen all of this stuff. So we're talking about the science of Star Trek Discovery. I have done an episode on Science of Interstellar on my YouTube channel on time dilation, if you're interested in that. But, I mean, maybe they'll do some time dilation stuff here. You never know. Okay, so let me see. Oh, and then we go to Stamets. And the only reason I put this here is just because I'm a dork. And it reminds me of something I was learning when I was studying physics, where matter and antimatter. And the cool thing about it is that when matter meets its antimatter self, so you have like a proton and an antiproton, or an electron and a positron. Whenever they meet, they obliterate each other and give off photons. And one of the analogies that my professor used when I was first learning that is if you were in an alternate universe and met your antimatter self and you shook hands, you would immediately explode. And I remember this because Stamets meets his other part in a parallel universe, and they touch hands and they exploded. Now, subsequently, they just went somewhere else, and he was showing kind of through the ship of this, but I couldn't help myself. So matter, antimatter selves, when they meet, they turn into photons, and that looks like what happened here until a second later, and that's not what happened, but we can still geek out about it. So now when Burnham is talking to the Emperor, and she convinces her in a not very strategic way. She just says, oh, we're from another universe. Please don't kill me. Different universe. And I can show you. And she hands over Giorgio's badge from the Prime universe and says, we have a different quantum signature than this one, and you can test it on this badge. And in order to prove it. Now, totally valid. Remember I said that if you have multiverse theory where you have what you refer to as quantum multiverse, sometimes that means that the fundamental quantum particles of universes vary from one to the other. So it's entirely plausible in this super theoretical physicsy way that you could have quantum signatures that could be detected from a different universe. And all it would be is have some scanner that could read down to the fundamental particles and see if they're slightly offset. Now again, I had some issues with this, but basically what it comes down to is in two previous episodes, episode 10, they were able to interface the electronics with the crystal and read it. And so I was like, well, how could you do that? But if you know the quantum offset, then you could kind of calibrate for that. And so that would be what the scanner is picking up, is it's reading that quantum offset from like a known, because you could read the chemical structure of the metal, which, is solid and dynamic, or solid and complex. And you would be able to see that the fundamental particles are going to be slightly off from that. So would have a different quantum signature. Now, this is all theoretical, but in the realm of physics theory, I'm happy with it. I think that holds up. So, carrying on from that, let me see. Yeah, Giorgio and Burnham talk about the different universes. And in a very non-Star Trek-y way, a humble opinion, but as a Voyager fan, Janeway had a lot of moments to like trade technology for knowledge and was always like, should we do that? Should we not? And Burnham was like, want to see how our ship works? I was a little hesitant about that, but hey, different Star Trek series. So she goes and she's explaining about this mycelial network and how they somehow ended up in this multiple universe, and that it's different from how the Defiant got there. And they go into a little bit of detail. So Giorgio mentions that it traveled through a temporal anomaly. And remember, we've had the Defiant show up in both the original series and Star Trek Enterprise. And on my to-do list is to watch those episodes again, so I can try to remember some of this. But the whole point is that they were trying to explain what the difference is between them. And Neostar said, to be fair, she did just watch a group of people get cut down. Yeah, I might say, want to see how my ship works? If I witnessed that like disc fly through a bunch of people's brains, which was gory and awesome. I loved that. So yeah, okay. Give me that one, that it's terrifying. So yeah, they try to talk about how, because apparently when the Defiant went into the mirror universe, there were issues. They had devastating effects to the crew. They had gone through a temporal anomaly. What the heck does a temporal anomaly mean? Well, as I've talked about in the past, when we talk about multiverse theory, we have our universe, which is the sheet of four-dimensional space-time. And then you have, and they say this word in here too, you call it interphasic space, or hyperspace in other sci-fi. Basically, all they mean is the space between sheets of universes. And so anytime you're traveling out of the standard four-dimensional space-time, you're going to be in another space. And so when we talk about temporal anomalies, those are going to be anomalies in a sheet of space-time. It's going to be some warped, it's going to be some sort of thing that makes the dimensions go all hooey. Now, we talk about time travel. What's going on is that you have your time dimension, which we have no control over, but it continually progresses, that somehow you're able to fold that dimension back on itself and go back to those coordinates. So they kind of mention that as some way that the Defiant ended up in the mirror universe. And like I said, I need to watch the original series again, or in Enterprise, to figure out how they explain this. But off the cuff, the way I would say is that there was some sort of temporal anomaly which caused a shift in the time dimension of the space-time in our universe, which would somehow interact and interface with the space-time in the mirror universe. Got it? Good. Great. Okay. So one cool thing that she did say, Giorgio just mentioned, is she says warp engines do not breach barriers between universes. Correct. That is absolutely correct. The way warp engines work in Star Trek is it bends the space-time of one universe in over itself, and it just stays completely within our own universe. It's just bending its own space-time. There's no way you could use that to breach through to another universe. So I'm totally good with that. The sort of offhand comment she made that warp engines do not breach barriers, so how did you do it? And then she's like, oh, I'll show you. Yeah, so that was awesome. Okay, so let's, all right, now we got to talk about this. We've got to talk about this. So let's imagine there's a star of some sort in the core of the Karen or Sharon. I usually say Sharon. All right, before we carry on, there's a question. If you go to warp 10 and are everywhere, are you also in the mirror universe? No, because you are, so for those of you who may not have been on some of these discussions that we've had before, when you go warp 1, that's, well, as we're using in this episode, it just bends up your space-time so you're flat. And then you want to go another level, you just bend space-time around you a little bit, so space-time goes faster than the speed of light, and you're able to accelerate through this bubble. If you want to go faster, you build another bubble over that, and then in theory, according to terrible Voyager episodes, warp 10 is the theoretical limit. And the reason is that you end up at all time and all space. And the way I interpret that is that you take the entire, you've basically reached the point where you're going up exponentially. You know, it's like this idea that if you're to like double, you know, you're double a bet, go double or nothing, within some stupidly small number of bets, you have the entire like gross income of the United States. It's a similar idea that if you're going up exponentially in warp, that eventually you're just going to like wrap the whole universe around itself, and you end up at all time and all spaces and eventually evolve into lizards. So when we talk about that, that would not, that none of that would interact with another universe. That we would have these sheets of space-time and there's nothing in between. There's like the hyperspace, interphasic space, however you want to phrase it, in between them, but they're never going to interact with one another unless you have this weird crap that's going on with this mycelial network. But the old theory way of warp 10 is that that would not happen. But again, I need to watch the original Defiant episodes to try to remember this stuff. So yeah, correct. Separated by orders of magnitude. Okay, so going back onto this ship, this weird powery star-like looking thing. There were so many cool pictures, I couldn't pull up all of them. But basically, you have looks like a normal, so we call them main sequence stars. Looks like sort of orangey yellow through most of its life, doing its thing, radiating out. Few issues here. First one is if it's actually a star, it's far too small. So yeah, I don't care how big you think this might be. We saw some scales with the shuttle coming up to it. It is far too small to be an actual ignited star, purely because the way that stars function is that you have this fusion that's going on in the core of it. And what happens is there's so much pressure from all of this mass falling onto it that it's causing hydrogen to fuse into helium, which it does for 90% of its life when it's a main sequence star, which looks like this. And so it requires a ton of mass. And so it has to reach a certain point. Now, if it doesn't reach that point, we think and expect that there's a lot of what we call brown dwarfs out there, which would be stars that are just a big ball of hydrogen that just never got massive enough to fuse that hydrogen together into helium that would then release a photon and release radiation. So this thing, whatever's in the core, is far too small to be just a standard main sequence star, which is what it looks like. So what else could it be? Well, it could be maybe a neutron star. So that's the core of a star after it's died. Now, they don't really radiate in the same way that normal stars do. So you take the mass of a whole star and you condense it down to the size of a city, possibly about that size. That might be a little small, but comparable. Like, I'd get away with that. and compress it down to the size of about that. The issue is that that's insane. Basically, if you want to get mass down that small, you have so much, like, it's neutron degeneracy pressure is the only thing holding it up. So it's basically the neutrons are so far in on each other, they're just barely holding up because of this weird quantum effect. And the only radiation we've seen from neutron stars is what we call pulsars. So that's when a neutron star is radiating energy, but it's such a weird environment that it's radiating like a lighthouse. So it's just beam of energy going up and down, and then it pulsar, like a lighthouse. So we just see these flashes, but it's spinning like that. So that doesn't really look like what's going on here, but the size is right. So to pull it all together, we have what looks like a main sequence star, which is hydrogen fusing into helium, but it is far too small to be that. And it's about the right size to be a neutron star, which is a dead star, but then it wouldn't look like that. So that's kind of where we're at. Could be something totally different. Could be, sci-fi technobabble. We can sort of get away with it. Oh, thanks. Glad you're enjoying it. So it's a bit tricky there. One thing that I did want to mention, because I have to, so the question is, what if it's not a star, but a massive ignited, controllable, fissionable material? Yeah, it could just be like an exposed neutron fusion, nuclear fusion going on. Because a star is just nuclear fusion, but for it to naturally be happening has to be really massive. So if you were somehow able to maybe compress to create the same amount of pressure as the mass of a star, then you can maybe make that work. Because that light and the radiation that's coming off of it is coming from things that are fusing together. So I like that. Totally artificial or artificially pressurized fusionable material. It could be fission, but I'd say given the way it looks there and given how much it resembles a star, I would say it's fusion. So instead of tearing things apart, you're compressing them together. And this reminded me of this. Now, this is not from Star Trek. This is an artist rendition of something called a Dyson Sphere. Now, a Dyson Sphere is, again, a totally theoretical concept, but it's something that we do when we look for when we're trying to find extraterrestrial life. So one of the things we think is if you have a super advanced species, technologically advanced species, one of the things that they might do to harness energy is they'd be able to build like solar panels all around their star. That you could get so much energy from that you'd be able to power your super technological society. So just a cool concept and kind of related to what looks like is going on here, that you have some sort of power being harnessed from the center of this, from whatever this object is, by the ship. And that kind of resembles a Dyson Sphere, which, does exist. And we talk about them. So pretty awesome stuff. And then the last thing we need to talk about is this idea that sensitivity to light is the only biological difference. Okay, now if you're here, spoiler alert, there's people here who haven't watched this sort of stuff. Is this considered a tier 2 species or tier 3? I think it's tier 3 if we're using the same scale. I've heard different scales thrown around for what you would consider like, this is the science of Star Trek, so we'll throw out an example from Star Trek, but basically when where the prime directive comes into play is what they call pre-warp species. So species that have the technology yet to go faster than light. And I think that's a tier 3, but I don't remember. So, but for those of you who don't know what I'm talking about, what we're talking about is some people have broken down sort of philosophically different technology sort of tiers for the intelligence of other species. So yeah, like I said, I've seen different scales, I've seen different things. And in Star Trek, we talk about warp and pre-warp. So you're a post-warp technology society and a pre-warp. And if you don't get to meet the Vulcans until you develop warp. So get on it, people. Okay, so yeah, if you care about spoilers, I don't know why you're watching this. And I'll come back to that too. But the end of the episode, they reveal like the sensitivity to light is the only thing that indicates biologically any difference between the two universes. I want to know how they know that. But apparently, so I thought about this a little bit. Thought, okay, well, how could you be sensitive to light in your own universe? Because originally I thought, well, maybe that it's the quantum signature of the mirror universe that would cause these fundamental particles to be radiating too much. Yeah, I think that's the Kardashev scale, but I don't remember exactly. Maybe someone can Google that, but thank you. Yeah, so possibly the radiation signatures that are just coming off of stars, just the general background radiation of our universe, could have an adverse effect on people from a different quantum multiverse because their fundamental particles would be slightly off. So the radiation would be slightly off. We talk about radiation, we're talking about alpha, beta, gamma particles. Alpha and beta particles are just hydrogen and helium type. Okay, thanks guys, you got this. When they talk about these different quantum universes, it's entirely possible that you could have weird biological effects because the radiation would be slightly off. So, however, she's sensitive to light in her own universe, and Burnham isn't sensitive to light in the mirror universe, and Lorca's sensitive to light in the prime universe. So the way they've done it is basically anyone from the mirror universe is super sensitive to light. And they leave it at that. No matter what universe they're in, I don't know if they'll explain it. I don't know if they'll try to. Like I said, my initial reaction was to kind of chalk it up to this quantum differences and quantum fluctuations, and that doesn't quite work if we're talking about who's sensitive to what when. But maybe we'll get an explanation. We will only wait to find out. So I think that's kind of it. For these 2 episodes. Wasn't a ton of astronomy science, but like I said, man, we got that thing in there about that shuttle going exactly the speed of light, and I don't know if they did that intentionally, but well done. That shuttle traveled 27 million kilometers in exactly 90 seconds, so we are not worthy. All right, let's see if there's any questions. Arcantrix, maybe if they hop universes, they become like Superman and get superpowers with the new light, like John Carter. Yeah, I mean, we could go down that route, right? But again, like, because the people from their mirror universe, where you're light sensitive, they're sensitive to light in the mirror universe, as well as the original universe. And the people from the prime universe, original universe, aren't sensitive to, there's not like a backward effect. It's not like they're less sensitive to light. Everything's really dark. So it's a bit tricky. It's not like sort of this idea of like Krypton either, where it's like different radiation. Could be an explanation, but the fact that Giorgio, when she saw the core of the ship, was like, oh, it's bright like that. That doesn't work. So yeah, I wish it was like the Force. It's not Force sensitive, sadly. So are they always sensitive to any light, or is there a loophole? I don't know, because so Lorca in the Prime universe, right? He's like injects his eye, and he seems sensitive to light in general, that it needs to be adjusted, that it needs to be, he needs to slowly adjust to it regardless. Similar with her, in the mirror universe, that she looked out her window, saw this bright thing, and looked away. And I guess their eyes can adjust to it, or you're able to inject your eyes. Or maybe that's what everyone in the mirror universe is, inject their eyes. I mean, but it also seems pretty easy, because goatees aside, it's pretty hard to tell the good guys from the bad guys. But if you just shine a light into them, then that's really easy. So yeah, I don't know. We will find out. But yeah. Any other last questions? If they're sensitive to light, that means when they kill Scotty, beams them up, they go blind. Right? You'd think so. Again, though, you just have to adjust to the light really fast. You'd have to have some way to compensate for the light in transporter pads. And that moon planet that they were on in the last episode seemed really sunny. So, but inject eyes. So, anyway, we'll leave it at that. Thanks for joining me. Like I said, I'll post this up to YouTube like usual. If you've not followed me in the past, you can find me here on Twitch, Dr. Erin Mack. Same handle on Twitter and Instagram. And then I'm on YouTube, Dr. Erin Explains the Universe. And where I have VODs, I have these VODs on Twitch as well, where I talk about the science of sci-fi, sort of 10-15-minute episodes, because science is awesome. All right. Well, thanks, everyone, for sticking with me. And I'll be back next week. Hopefully, we'll see the new episode, see how it looks. And yeah, thanks for joining. Live long and prosper. Catch you later. Bye.